We continue down the journey that is Unit 3 with Section 3.2. Now, yesterday we talked about the laws of exponents that you should have really learned probably in 7th grade, and then practiced in 8th, and then 9th, and then 10th. And well, basically, you've done them a million freaking times. But today, rational exponents. I don't really know how many times rational exponents are taught before Algebra 2. I think they're taught in Algebra 1. Pretty sure I've heard my wife talk about this. But rational exponents, the word rational means fraction. Yes, fractions, okay? We're talking fraction exponents. Yes, they're a thing. Fraction exponents are radicals. Radicals are fraction exponents. The rule, which is in the box right there, shows you that a standard radical, third root, fourth root, fifth root, is the 1 over third power, fourth power, 1 over third power, 1 over fourth power, 1 over fifth power, so on and so forth. That's a very loud noise that my computer just made. So the square root is, wow, okay, we'll try that again. The square root is the same thing as saying the 1/2 power. Because the square root is the only root that we don't write a little number there. That's called the root index. The square root's the only one that we don't write the index, but it is technically a 2 sitting right there. Technically. We just don't ever write it. So if you say the cube root, you're saying the 1/3 power. The fourth root, the 1/4 power. But the thing underneath the radical, it could have its own exponent. Well, that could still be part of the exponent. So if we have a fraction exponent, instead of just saying 1 over n, we could say m over n. Basically, the bottom of the fraction is the root type. The top of the fraction is a true exponent. And that true exponent can either be written inside the radical or outside the radical. So it's not written here, but this is the same thing as saying the nth root of a all raised to the m power. You could use the m power either in the radical or out of the radical. Whichever one makes your life easier, that's the one you use. Sometimes the m power being underneath is easier. Sometimes the m power happening after the root type is easier. You do whichever one's better for you. Our calculators can do this quite easily because our calculators raise things to fraction exponents. Or you could just use root types on your calculator. Yes, your calculator can do the fourth root or the fifth root. It can do that stuff. And I am remiss, I did not have this program open yet to show you where it does it. So while it opens, we'll just do some examples and then I'll show you how to do it on the calculator. It'll boot up in just a second. Maybe. We'll try it one more time. There we go. Now it's opening on my other computer. So let's do these first examples, and then I'll show you how to do it on your calculator. Just like yesterday, we're going to write these things as powers of 2, just like we did yesterday. Only now, these powers of 2 will be fractions. Well, for part A, that is simply the cube root of 2. So that is 2 raised to the 1/3. There it is. The 1/3 root of 2. Or the 1/3 power of 2, excuse me. Now, for B, that radical, we should recognize that radical as being a square root. We should recognize the square root as being the 1/2 power. But that radical 2 is on the bottom of the fraction. So what that tells us is our power of 2 would be negative. Yeah. Because 1 over root 2 is 1 over 2 raised to the 1/2. So I can scoot that 2 raised to the 1/2 to the top and call it 2 raised to the negative 1/2. Now for C, these are all supposed to be powers of 2, not 4. But 4 is a power of 2. 4, that looks like S. 4 is 2 squared. And remember what I said, the root type is the bottom of the fraction exponent. The exponent is the top of the fraction exponent. So for C, it's just 2 raised to the 2/5. The root type is the denominator every single time. Yes, ma'am?
For part B, I thought we didn't want negative powers.
We don't want negative exponents in our answers, but because they specifically said write it as a power of 2, just because that's the way the directions we're expecting it. But if it hadn't said that, you wouldn't have left it as 2 raised to the negative 1/2. No. Yeah, this was just because they were trying to see, could the student manipulate it so that it was a power of 2? And there is a reason why we're doing that, which will come up very, very soon. Manipulating it to look like something else is a thing we do a lot in mathematics. Yes, Aaron? Yes?
Why don't we put 4 to the power of 1 over 5?
Well, what we wrote 2 to the 2/5 is the same thing as 4 to the 1/5. It's the same thing. But the reason why we didn't do 4 to the 1/5 is because we were specifically told we need to use a power of 2.
Okay.
That's the only reason why. So yeah, that 5th root of 4, that is 4 to the 1/5. But it's the same thing as 2 to the 2/5. Exactly same thing. It's only because the directions told us to. So I want to fire up the calculator real quick so I can show you how to use the commands. Come on, move on over. There we are. That's another graph I did a while back. Clear. All right. So how do we access, well, first of all, fraction exponents is easy. If you have the newest operating system, I could just say, 2 raised to the, well, now it's waiting for me to type something. I can either use a stacked fraction, or I could just write, like, I don't know, 3/4. 3 divided by 4. And it kept me in the exponent position. And it will keep me in the exponent position until I hit that right arrow. And that's what it's trying to show you. It's telling you hit the right arrow if you want to get out of exponent. Now I'm not in the exponent position anymore. Now I'm back in the exponent position. Or if you like stacked fractions are in the math command if you have the newest operating system. Math, frac, n over d. And now it's waiting for a stacked fraction. But because I was already in the exponent position, I didn't have to use the stacked fraction command. Let's go ahead and clear this. What if it's a 3rd root or a 5th root and you don't want to use a fraction exponent? Your calculator can do that also. Structures are all in the same spot. Math. You see 5? The x root. So if you type it, it's waiting for you to type the root index. Say the 6th root. And then you just hit to the right. Now I could say, what's the 6th root of 5? Good gravy, that's a lot of emails. But there, that's how you use x roots. Okay? So you can either use x roots or exponents that are fractions. You can use stacked fractions or side-by-side fractions. Either way, you just make sure that you are adept with your calculator technology. Also, one I showed you, but I'm guessing a lot of you didn't remember come test time. I think maybe one person in the entire class remembered. But math is where your what's the word I'm looking for? Structures are. Math is in structures. Or structures are in math, excuse me. And absolute value is right there. I showed you this once before, and it was necessary for the test. But that's absolute value. Anyway, okay, so back to our notes. Let me see your calculator. It can't do a stacked fraction. You'll have to, so for that one, you have to do side-by-side fractions and make sure you use parentheses. That way it knows when the fraction's beginning and when the fraction is ending. Yeah, that's the same one I had in high school. You just get really good at using parentheses.
Pretty much. That's actually
Oh, look, these examples legitimately just say to use your calculator to evaluate. There's not even any work to show. You just type it on a calculator. So what is 2 to the 7/5? 2 to the 7/5. Yikes. Well, let's find out. Calculator. 2 raised to the 7 divided by 5. Oh man, I'm just going to type it. I don't know the answer. There you go. To 3 sig figs, that is 2.64. Okay, 2.64. Woo. And for B, you don't even have to use stacked fraction. Let's say you're using a calculator that can't do stacked fractions. 1 divided by cube root of 4. I could do this. 1 divided by math. Look, the cube root is a hotkey. It's 4. then you say enter. To 3 sig figs, actually to 3 sig figs, that is 0.62. Because that fourth decimal, that 9, bumps the next 9 up to a 10. So it's 0.63, excuse me, I think I said 2. 0.63. That is 3 sig figs. I think technically I'm supposed to put 0.630, but math IB that'll never happen, so you don't have to worry about it. The only thing I could do for those examples is just show you how to use your calculator. So if there's anything you'd like me to show you again or do in a different way, I can. You know what I mean? But we're just learning how to use our tech. Okay?
How would you write regarding with the answer we got in 6.69?
How did I get to?
No, what would you write? What figure would you get?
Well, so for 3 sig figs, you look to the fourth significant number,
Right.
which is the fourth number that, as long as the first number wasn't a 0.
Right.
So the first number for ours is a 0, so we ignore the 0.
Right.
So we get 0.6299.
Right.
So we get the fourth decimal to round the third decimal appropriately.
Right.
Well, unfortunately, that bumps us up to only 2 decimals. So you would write 0.63.
Okay. Sure.
Mm-hmm. In fact, if you did 4 sig figs, you still get 0.63.
Mm-hmm. That's
Yeah, you'd have to do 5 sig figs before you got anything other than 0.63.
Yeah.
And to be honest with you, on the IB exam questions, they never have a fourth decimal round a third decimal to a 0. They always make sure that their 3 sig figs is not a 0 at the end. I've never seen it be a 0 at the end. And these ones at the bottom, it says, hey, without a calculator, write this in simplest rational form. That means no exponents allowed. We should be able to evaluate these without a calculator. So for A, what we have here is a cube root, right? Because the denominator is a 3. So I'm dealing with a cube root. If we use the book's definition only, you'd have to do this. That's if you use the book's definition that was in the box. So who in the room knows what 8 to the 4th power is without a calculator? Oh, that's right. Notice how I didn't raise my hand?
right off the top
It's a big number. I know that. It's a big number. I don't know what 8 to the 4th power is. Why would I know that? But you know what I do know? I do know what the cube root of 8 is, and I'll just raise that number to the 4th power. You see, that 4th power can be moved inside or outside. It's completely up to you. Well, what's the cube root of 8? 2. So this actually says 2 to the 4th power, which, and that one I should hope you could be able to find with your fingers. 2 times 2 times 2 times 2 is 16. I believe that 8 to the 4th power is 4096. Would anybody like to check me? Is it 4096?
Yeah.
Okay. Flexing those math skills. If you're not quite sure on what's going on here, please say something, talk to me. Let me help. Everybody's calm, cool, and collected? Cool. We'll move on to B. Oh boy, 27 to the negative 2/3. Yikes, right? Right, well, check it out. First of all, negative exponent. Negative exponent moves things to the bottom of a fraction, and then the exponent becomes positive. So let's just start it by doing this. That's a good place to begin. 27 raised to the 2/3. Now, we do the same trick we did for part A, but it's all happening in the bottom of the fraction. So I'm going to save that exponent of 2 until after I have reduced the radical. So I'm going to say the 3rd root of 27, and then after that, I will square it. Because I would hope that you know what the 3rd root of 27 is. It is 3, because 3 to the 3rd is 27. So I have 1 over 3, and that exponent of 2 is now evaluated, and I get a 9. 1/9. And that's why the answer is said in simplest rational form. Rational means fraction. Because the answer is 1/9. I think that's it for the notes, isn't it?
Yeah.
Easy peasy lemon squeezy.